Priyank Patel teaches geography at Presidency University in Calcutta. His primary research interests center around rivers through examinations of their geomorphology, geochronology, and ecological attributes and assessing fluvial hazards. His related research domains are the use of high-resolution geospatial datasets for landscape mapping, especially using UAV and ground-based SFM and LiDAR methods. He has taken research projects on gully mapping and soil erosion, use of nature-based solutions for mitigating riverbank erosion, stream restoration in urban areas, and anthropogenic impacts on river systems. He likes to say that he thinks what he does is important, but knows it is time pass. And today he will be talking about how this sand mining activity is changing river morphology and ecology. So, yeah, over to you, sir.
Very good. So, first of all, thank you to Dr. Catherine Russell and the ASN team for having us, allowing us to speak today. We will try to keep it brief and not make it lengthy or tedious. So, what I will talk on very briefly is because we have two other speakers and they will be talking on related topics, basically leading up from this is converting rivers to pools. And this is talking about anthropogenic signatures, that is how humans are modifying rivers, especially in terms of sand mining in India, and why we feel that focusing on these signatures, trying to document these signatures is important, and what is actually happening on the ground. And from where I end my topic, our next speaker, Suraj Gupta, will pick up from there. And then we have Siddharth to talk about some wider ramifications of this issue. So I'll just begin to not take up any more time. So converting rivers to pools, we are looking at how human induced or human demand driven for sand is changing riverbeds across the world, especially across India. And what are the signatures that we see from satellite images, from maps on the ground of such changes on rivers? Now, so, where did we start off from? So, the inspiration for this work comes suddenly one day when, while just going through Google Earth, I happened to see an image like this. And this is an image of the river Kaveri in southern India at a place called Tiruchirappalli. It's a very old town, big temple town once upon a time. And this is very striking, or this was very striking for me because you see, the Kaveri River has two strands over here. It splits into two bits and then joins again. But then you would only call one of them a river, right? Because the northern part or the northern channel, all you see is a series of rectangles, a series of pools that have been dug into the riverbed from where the sand has been hollowed out. While the southern part, that is more resembling what is a river, right? Or a dry season river when the water level has gone down. So this is something that struck with us. And we thought about that if we can really see what is happening on the ground, is there any documentation of this? Because we read a lot of reports about sand mining. It's always in the news. Sometimes it's an election issue as well, because especially West Bengal, where I live in Eastern India, we are actually going to the legislature polls tomorrow. And one of the issues has been sand mining in the past and how these resources are being utilized in the state and by whom. So, our study commences from here, where we want to see that where else do we find such signatures? Can we really document them? Is there any mention of them in the geomorphic literature? And can we build a database of such things? So I went back to look at the literature, and this is a report by India Rivers Forum. Our third speaker today, Siddharth Agarwal, he is part of this forum, so he will be able to give you more insight into this. So what they did, they made a report in 2020, which looked at sand mining in India. This is for South India. There's a report for North India as well. And they documented some states where they looked at what was the demand for sand, what was the supply per annum of sand. But it is not something that has been happening in India or being, done in India just from 2020 onwards. We have the National Act from 1957, which governs the mining of sand in the country. Also, for a long time, this is the act that has been stated by various states to extract sand from the country. Then there are the 2016 sand mining management guidelines. the 2018 sand mining framework. But even then, we have had repeated questions in the Indian Parliament on illegal mining from rivers, on how this is changing rivers, on the dangers it poses to communities. And I just want you to keep looking at the map on the right, because the states that you see in gray, they are some of the most densely urbanized states, especially West Bengal over here in eastern India. But it seems that there is a shortage of data. There is an acute shortage of data on how much sand, from where, what are the rates, what are the seasonal variations. So that there is really a deficit of data set that has been there. Very often governments have allocated sand blocks, but then monitoring them, seeing how much sediment has been extracted, that has sadly fallen by the wayside, or it has been underreported. Now, West Bengal governs and manages its sand extraction using this Gazette notification in 2022. This is known as the West Bengal Sand Mining Rules of 2021. And based on this, every district is required to prepare a report. And now this is uniform throughout India. Every district in India is required to prepare what is known as a DRS, or a district survey report, which will document how much sand is there in the rivers, how much can be extracted, and basically not just sand, all other minor minerals, because sand is classified as a minor mineral in this country. So every state is required to prepare one such report for each of its districts. And I think our third speaker, Siddharth, will give you much more insight into these DRS, their effectiveness, and what they do well, what they sometimes don't do well. But in spite of making these DRS, there are still questions and press notifications being issued by the government of India on sand mining, on what are the issues regarding it. So this is an issue that is still largely unresolved, that is pressing, and primarily that comes down to the lack of an adequate database, the lack of really pinpointing what is happening where, because sand blocks in rivers, they are auctioned, and people take these blocks on lease, and they are said that you mine within a certain area, you extract so much volume of sediment, but exactly how much is going on, that remains a question mark. There is an entire alternate economy on through illegal mining of sand, sand mafias that are there, daytime mining, which is largely legal, versus nighttime mining, which is much more illegal. So these issues are there. Going back to the image that I showed you, what are the ways in which this sand is extracted? And this is taken from a very good book called Sand Mining by Padmanal and Maya. And so they talk about the various types of sand mining that happen in India, largely in-stream mining, so mining from within the river channel, floodplain mining, extraction from the floodplain, and then terrace mining, mining from the higher parts of the river terraces. And within the channel, when we talk about within the channel mining, you can mine from within the water level. So this is something that happens in many parts of the world, especially sand mining in the Mekong, sand mining in Vietnam, along rivers of Vietnam, Mekong, and other rivers. That has largely been in focus over the last decade. And there are a number of big research papers or insightful reports on this. Specifically there, sand is extracted from below the water surface. So you have dredgers on boats, or you have extractors on boats, and they pump up the water, and then you filter out the sand. And so the signatures of mining, they are hidden below the water surface. Of course, if you do a eco sounder survey, you can have a look at the bed roughness, how the bed topography is changing. But in India, especially in the peninsular part of India, especially in the Himalayan foothills, where rivers often run dry after the monsoon. Our summer monsoon is from June to October, and then the river water levels largely go down, and then we have a dry period from November to the next May. Of course, climate change is inducing changes in this temporality, but as the water level goes down, these channels become more exposed, and we start to have bar scalping, where people can just skim off the bar surface. They can hollow out into the bar surface, and you can have sand mining both from the exposed sandbars, that is dry pit mining, or you can still continue mining it from below the water level, which is wet pit mining. And these four methods in orange here, they are the most prevalent methods that we see throughout India, where, because accessing the bar is easy, you don't need a sophisticated boat. You can just go in. You can have artisanal mining, which is manual, or you can have JCBs and excavators, mechanized excavators that will do the mining for you. So looking at this, so we started to look for signatures throughout India, and we found a wide range of it. So if you see this river, this is Damodar. We'll talk more about it. how it's like it creates a fan-shaped pattern. This activity creates a fan-shaped pattern where trucks and excavators are accessing the river and creating entire different landforms. And this is what I wanted to focus my talk on, because when we study geomorphology, when we look at the landforms that are created in all our textbooks or in most of our discussions, we mainly go back to naturally created landforms, right? So you have river land, you have fluvial landforms, you have glacial landforms, marine landforms. But there has been a movement over the last 15 years, led by Sabo and others, where they talk about anthropogeomorphic landforms. But in our standard textbooks, in our regular study materials, this is still underrepresented to a large event, and especially these landforms that are there on the riverbed. No river has made them. These are all made by humans, actors, which are interacting with the river sediments, interacting with the water. So we thought that we should go ahead and document these landforms, create an inventory, a database of them, try and classify them, and at least build up the literature in that manner. So you can see that there are, you get different patterns throughout. For example, this is the Dharla River in northern Bengal and bordering Bangladesh, and you see this entire river has been hollowed out with circular pools. And so this is not something which is made naturally. This is human made. Or you go to South India and you see a rectangular pattern of landforms. So, different parts of the country, they keep showing different ways, different methods of sand extraction. And that's a very interesting regional variation that we have been able to document. So based on this, it took us a lot of time, but we actually ended up pinpointing the sites throughout India where such sand mining locations are there. We used high resolution Google Earth images excuse me, high resolution Google Earth images for this. And over a period of time, we zoomed in, we tried to pinpoint each of the locations where this is. Now, of course, this is tentative because sometimes images are dated, they are not of high resolution, or the places keep changing. And one of the good examples I can show you is on the right in the Mahanadi River, again in a state of Odisha in eastern India, where you can see how a natural sandbar, how that gets transformed over time, and you have the tentacles of the roads that are reaching into the sandbar, and eventually only these tentacles are left on, and the entire volume of sand in between has been excavated out. So we try to do this documentation throughout the country. We believe this is one of the first such inventories created at the national level, and this is quite crucial because this can really guide policy and planning, knowing how much extraction is happening, what are the sites of extraction in each river basin. So based on this, we find some of the highest densities to be in West Bengal, and I will go into this location further into these rivers of West Bengal. So if we go to West Bengal, how does it look? How does it look? It looks like this. And you go to the riverbed, hardly anything is natural. This is the Damodar River in southern Bengal. You see rows and rows of excavators that are standing, trucks that are standing, hollowed out bits of the river. Or you see large piles of sand, large mounds of sand, taller than 2, 3 people combined, and they are occupied. They are covering the entire riverbed. So we thought that we should try and document this, try and map these things. This is a drone imagery from northern Bengal, where again we are seeing both wet pit mining, pools that are being created by mining, flattening of the bar surface by extraction of the sands that are there. And so we try to document these things over time. Before that, we thought that is it already documented? Is it already listed in the literature? And so we did a survey of the sand mining literature that is there. And what we found quite strange that there are specific domains where people have worked and focused on. This is people have worked on dredging and sediment and how it affects river flows. They're talking about ecological impacts, the types of minerals that are being obtained, especially in Central Africa. Mining from riverbeds is done for gold, copper, and other precious metals. And of course, there is a lot of discussion on sustainable mining policies, what are the governance issues that are there, so on. But we did not find any single literature or that explicitly talked about the inventories of these landforms, mapping these landforms at the national level, or if there are, they are quite vague. So we started about documenting this, And for the first time, we classified them. We tried to give some names to them. For example, sand hollows, where if you mine up a bar surface, so you reduce the elevation of the bar surface. So the inside bits are lower, the outside bits is higher. Sand pools, you mine it so much that water seeps in. So basically, sand pools are problematic because as per government guidelines, you're not supposed to mine below the water level. So wherever you are seeing sand pools, that means excavation is happening beyond the permissible limit, right? Sand mounds is where sand is being piled up. Sand tracks are the roads that are being created on the temporary roads that are being created on the bar surface to access these mining sites by trucks to take away the sand. And sand bridges are the temporary fords by piling up sand that are created across the rivers to access different bars for the mining purpose. You can see that this is also artisanal. You can have one person mining and creating a large sand pool in a river, and you can see how turbid the water becomes. This is from the Shilabati river, again in southern Bengal, where because it flows within a ferricrete or an iron oxide rich landscape, substrate landscape, you have the iron oxide materials, those gravels coming and meeting the water, and it makes the water very, very turbid. So you have very high turbidity values. And our second speaker, Suraj, will talk about these changing turbidity values in these rivers due to mining. So we started documenting these. So just to give you some idea, these are the kind of nomenclatures that we could propose. These are the kind of labeling that we could do both from field photographs as well as from satellite images. So from Google Earth, we zoomed in throughout West Bengal, other parts of India. I'll show you West Bengal mostly, so I can because we have much more data sets on that region. So we could digitize each of the various features that are there, pools, hollows, sand tracks that are there, and over time we built up a database. Right, so this is an example from the Subarnarekha River, and this is February 2022, where we are documenting these features that have happened on the river. And I'll tell you why this is important, because in 2022 you have this point bar, large point bar. You have sand pools that are hollowed out over here, and then what happens, because you hollow out the bar, you create these pools. This offers an easy passage for the river to connect through during the next monsoon. And that is exactly what has happened if you see the lower satellite image in 2023, where the river has taken an alternate course through this channel. Now, what are the ramifications? This part of the river bank, which was largely stable, which was protected by a large point bar, now suddenly it is exposed because the river has shifted further south. The main channel has started to shift southward, and now it is attacking this river bank, posing threats of river bank erosion. So this is some of the main ramifications that we have of trying to document these things. Again, using Google Earth images, we're able to track the progression of these mining features over the mining season. So the mining season will start in November, and you will have a bar surface like this, largely freshly covered sand. You'll have a few roads that are starting to go out into the bars, and you'll have some hollows or pools that are being created on the bar surface as the sand is being slowly scooped up. And then as the mining season progresses, within these roads, you can see more and more sand is being cooked up. You will see different color tones water. The main river has darker tones because that is deeper. But in these pools that are more turbid and where sand is being hollowed out and mined again and again, the water is being churned, the water column is being churned again and again. You have higher suspended sediment concentration, so they show up very differently. And by the end of the mining season, all you have are these skeletal networks of roads or these tentacles that went into the older point bar, and you have the entire sand extracted between them. So this is a scenario that plays out between November to May during the mining season. And I often get asked this question: so does it matter? Because again, you will have a monsoon, again, you will have sediment coming in and filling up these areas. So will it not reset the entire landscape? Why is it important to document this? Why is it important to map this? What we can show you through evidence, which I will, is that once we end up mining beyond a certain limit, and there are local geomorphic thresholds throughout, once we end up mining beyond a certain limit, the same pattern continues to persist. So even if you have a monsoon coming in and filling up the sand all over again, you still have these hollows, you still have these remnant mining areas that are present. And then next year, again, the mining commences over there. right? It is only we see if you stop mining for a period of a few years, if the river has enough sediment coming in, that it is able to recover some of these bars. And even then, large tracts of the rivers, they remain as hollowed out pools. The water is much more stagnant. There is less, rapid flow, and there is a disconnectivity. There is a longitudinal disconnectivity that happens. So to assess this, we did the longitudinal mapping of these features, that is mapping them over time. So you can see the same sandbar in the Subarnarekha River, how from 2016 to 2021, how that entire bar surface is slowly being consumed as the mining signatures get spread out into the landscape. And I think this is one of the first such documentations that has happened in India, at least, of such signatures that are being captured. And so we could prepare an inventory of this, and we are able to get different patterns. We are able to highlight the various mechanisms, somewhere rectangular mining, somewhere circular mining, somewhere stretching out like a bird's foot in different direction. So we're able to document these patterns, and we're seeing this throughout rivers of the region. That is throughout southern Bengal, each and every river that is there, we are able to show that such features are present there. So based on this, over the last, for the last 1 decade, we have been able to document where mining has happened, what are the signatures of mining, what are the total coverage of mining that is happened in each reach. So we divide each river into a 1 kilometer stretch, and within each 1 kilometer stretch, what is the extent of mining that is happening. And so we ended up getting these kind of statistics. What is the growth in the sand hollows? That is more mining. What is concerning is we are seeing much more growth in the sand pools. So that means you are having mining beyond the permissible limit, more and more mining that is taking place. And there was a rapid rise till 2020. And then this we found to be very interesting because we had the COVID pandemic induced shutdown. And so the actual geomorphic signature of a pandemic in the landscape, because the mining industry shut down, and what happened as a result is you had a temporary slowdown in the mining industry. And then again, 2021, West Bengal started with its sand mining governance framework. So again, there was a brief stoppage in the sand mining, but again, towards 2024, this picks up. And we found this data set to be very interesting because disease, pandemics, they are leaving behind a geomorphic signature in the landscape through human action that we can document through these kinds of sand mining. So it brings in many different sectors, many different aspects interacting together to create such a data set. So we can deduce these kind of features, how mining is happening and what mining does. And Suraj, our next speaker, will talk about this more extensively because you create a series of hollows in the riverbed. The river narrows down, it connects through the hollows, it narrows down, it incises into its own bed. And so the main bed of the river itself, that becomes narrower, and the former bed starts to resemble more and more the abandoned terraces or the remnant terraces that are there. And so the river starts to transform, it starts to narrow out, and there are channel geomorphological changes that happen, which he will talk about. And the one great way to document this is using UAV imagery and using structure from motion to create the 3D landscapes in these areas. And this is absolutely crucial. Why? Because Google Earth imagery, satellite imagery can tell us where mining is happening, but not how much is happening. For example, if a government policy mandates that you can mine up to a 2 meter depth, what happens if somebody mines up to a 3 meter depth? What about that extra meter? What about that extra volume of sand that is extracted? We cannot assess this from 2D images, but 3D images, repeated drone shots, they can show us how much is the drop in the bar surface due to mining, how much excavation is taking place in which region, and we are able to document these sand mounds, the sand roads. We are able to document them very, very clearly and assess what is the sand volume extraction that is taking place. Again, if we have we have done surveys at different periods of time. So if we do a DTM of difference, if we subtract the two DTMs, we're able to see which are the net replenishment areas, which are the net loss areas that are there in this landscape. We can also create detrended DEMs, or what we call relative elevation models. And this is from a very high resolution data set of 2.5 meters, where along the entire Mayurakshi River, we are able to show where are the sand mining pits and hollows that are there. And they show up very, very clearly on the riverbed because these DEMs are captured during the low flow season when there is no water in the channel. And they are and detrended DEMs are a very good way to highlight the relative elevation changes rather than the absolute elevation variations. So we can map these things, we can show these kind of pits and hollows that are there and how we are actually transforming our rivers into pools in the natural landscape. And so we can assess here the same cross sections for a DEM dataset, a UAV DEM dataset in April and December of 2025, how much volume of sand has been filled up, where the sand has been filled up, where these river profiles are changing. And using these data sets, we can do hydraulic simulations, 1D, 2D hydraulic simulations to see what are the flow variations that are happening within the channel. So I'll end with one example from North Bengal, and where we looked at the Chel River. Again, this is a pre-monsoon DEM and a post-monsoon DEM. And we wanted to find out where extraction was happening. So you can see very clearly the sand mining signatures are very different from the natural signatures. On the right here, you have the natural river flow. You have a natural braided condition. So you can see the intertwined channels. And on the left here, you have these mining pits and hollows that show up very clearly in the DEM dataset that is produced through UAV imaging. And so we can identify by doing this DEM of difference, we can identify where there is net erosion areas, where there is net deposition areas. So we can see, superimpose them together, and we can calculate overall what is the net sediment extracted from this reach, along which part of the cross section is there sediment gain or there is sediment loss. And what we find, at least in this stretch of the river over here, it has been overmined. And so there is a net loss of more than 50 meter cube, 50,000 meter cube of sediment during the mining period. And what this may then do is it will underload the river in this stretch. It will make the river hungry for more sediment because the water is underloaded. We have manually dredged away the sediment. And so it might induce what Condolf and others have talked about, a hungry water effect, where the river starts incising down into its bed, where it starts to pick up more sediment from the riverbed itself and attacking the river banks, thereby inducing channel instability. And we are able to document mining signatures near bridges. And this is dangerous because there are very clear government guidelines that no mining should take place near bridges because it will destabilize the bridge piers and it will create problems for the road network over there. So these are the results that we are able to find out. Some of our published articles, if you're interested, please go through this. So we're able to map new landforms. We can document river course changes. We can show how rivers are narrowing and incising into their bed due to sand mining. And we are able to integrate data from different platforms to bring up these data sets and or to bring up this information. And this has good implications for the sand mining policies because, as I showed you, the DSRs that are there, they talk about monitoring, they talk about governing, monitoring regularly, but there are no established government mechanisms of how to do this, when to do this. So it is on us or to document these landscapes, give feedback on whether the policies are being implemented clearly or not, or what are the lacunae. And I'll just end with showing you this UAV video clip where we are going along the Mahananda River in North Bengal. And I want you to notice the two sides of the river. On the right, you have the natural riparian landscape. So you have vegetation landscape, the natural floodplain. On the left is where mining excavation has happened. You can see the sand mounds that are there. By now, you can recognize the various sand mining features within the channel, the hollows that are there, the sand mounds that are there. And you can see how the vegetation in the floodplain landscape has been modified. You have entire dumping of sand. We will call these positive landforms because they are landforms of accumulation. Within the channels, the dredged areas are the negative landforms because their sediment has been scooped out. And what we learn from this is sand mining not only changes the channel within, but also it will change the riparian zone because you will remove the vegetation. Or it will change the water quality. And we will go into more of this in the next speaker. So wherever we are getting more of sand mining, we are getting higher turbidity and lower dissolved oxygen. So that has ramifications for the aquatic habitat. Wherever we are getting more sand mining, what we are seeing is NDVI values, that is the vegetation robustness or vegetation coverage values along the river, wherever sand mining is taking place. There vegetation removal has happened, so that vegetation is poorer along the riparian zone. So that again induces riverbank erosion. And we see this throughout the rivers of southern Bengal. Wherever there is mining, vegetation values, riparian strip quality values, they are lower. And we can document these changes over time using multi-temporal data sets. And this is a framework that we have come up with on how mining creates loss of longitudinal connectivity. It creates loss of riparian vegetation, reduces ecological quality, reduces the water quality, and overall it reduces the entire riparian and river morphological quality in the mined reach. So I'll stop here. Our third speaker today has founded the Veritum Foundation, and he has proposed something very interesting called the Sites of Violence framework. And I guess he will talk more about this, how sand mining is not just a physical process, but also a wider socioeconomic aspect that needs to be examined. And there is a study from the University of Berkeley that talks about how India's sand mining bans, they were both good for the river maybe, but they also were bad maybe for local livelihoods. So it is an area where there is no absolute guidelines maybe, because we want the sand, but how much of the sand we want, how is it regulated, that becomes very important. So thank you for your kind patience. These are the funding acknowledgements, others who have helped us in this work. So I'll pause here. Thank you.